everybody. This is Jacob with 44 Africa again. I've got a knife I wanted to share with everybody. I'm really excited about this one. This is a little bit of a first for me. This is a prototype sheath design, and also the knife inside this sheath is one of my own design. This is one that I've designed based on my experience as a bladesmith and also my experience as a knife user. First off, I'll walk you through the sheath design that I've got here, because this is completely different from anything that I've really ever done. I like a lot of options in a sheath, and this one has a ton of carry options. So first off, it has the internal wooden and synthetic liner inside it. So there's no chance of a cut through in the sheath. There's no chance of a penetration through the bottom, just like in my other sheaths. That is something that is carried over. Well, I've got two straps put on here, which allows you to run a belt through it and carry it horizontal along your belt. Of course, you can do it on either side, left or right. So that means you can carry it really tight cross draw on either side. You can fish through. You can carry it small in the back where it just sticks out back here. You can also go lefty. This also gives a place for a pack strap to be able to slide through, and then you can wear it on your pack this way, or molly straps will fit through here so that you can fix it to a military style belt or vest. But I did go ahead and put some traditional style D-rings on it, some brass D-rings, and this paracord loop. And what this loop allows you to do is fish this thing, your belt through. And what this does is it gives you the same cross draw carry, left, right, wherever, but it gives flexibility. Okay, so if you're doing a lot of squatting or climbing or sitting in a chair for long periods of time, you don't want this thing digging up against your gut, really tight against you. So this allows this thing to basically just kind of sit in your lap like this. And you can get up, you can squat, you can climb, whatever. You can slide it out of the way to the back. It just gives a whole lot of flexibility, but it's super secure and very, very comfortable and easy to put on and off with your belt. Sitting for long periods of time, especially if you're a still hunter, which I do a lot of. It's very important to me that it's comfortable when you sit. What gets really unique about this sheath from everything that else I've made is the retention system. I've got a two-level retention system in this sheath. The most secure level of retention is just from this simple strap right here with a pull button. And you'll see how this actually works here in a second, but with it in here, with this simple little tie down on it, it's not coming out. I mean, it is not going to come out of there. You cannot drag it out. If you look a little closer, you'll see why. I have a piece of thermoplastic or Kydex that is running right here, a very heavy piece that has been heated and trimmed around, and it curls around the guard and has a hook. That hook, you just run that paracord through and pull the cord to, and it prevents this from being able to open up. But the second level of retention for this comes in that clip. So as we take this off, and we'll come to that, slips over, and then you can take this and tuck it in your belt or wherever. But we have a retention system that will still prevent the knife from falling out. Not coming out, but if you watch right here, it's a spring, and that's not touching the blade. Allows it to come out. As it hits that point, it's going to clip in and over, and now it's in. Yeah, so that's the sheath. Now to the knife. This is 52-100 bearing steel. Very, very hard steel, but it can be heat treated to where it has a certain level of flex and just a really superior toughness and edge retention. This particular blade has been differentially heat treated. You'll notice that the blade from the handle is dropping. It has a continuous angle that's dropping down. And then the cutting edge is parallel with the handle, with the core of the handle. Now the handle has a little bit of a drop at the heel, going toward the pommel, but it's 90 degrees right here. The cutting edge is 90 degrees with this main section. The other aspect of this that I put in is a continuous distal taper. So from here all the way out to the tip is a continuous taper. It is getting thinner and thinner as it draws out. So this has got an exceptionally fine tip on it. I also did a differential bevel for the cutting edge. So you can actually see, if you look at the shine at the edge of the blade, you can see that it comes up a little higher here, and gradually as we go forward it gets closer and closer to the edge because of the geometry of the blade. It naturally wants to have a little bit more thickness here and less up here with the taper of the distal taper of the blade. So it you've got all this real estate, and you use different parts of the knife for different things. You might as well have some differential edge geometry that's going to aid in those particular jobs. So if I'm batoning with this knife, I'm going to be batoning here mostly with it. I'm going to be working with smaller pieces of wood to make kindling with, so this is the area that I'm going to do that in. I'm not going to be bashing it into anything up here. So I can have a more robust edge here, and I can have a finer edge up here. This is basically set up to be high speed, low drag. Let me explain this too. This is something that a lot of people don't. If you're not a knife person, you don't use knives, you're probably not going to appreciate this. But for those of us that do, this is a key thing. These are the things that make a knife outperform your store-bought stuff. Okay, because it has this forged in distal taper all the way up, because it has a differential grind all the way forward, getting thinner and thinner and finer and finer. When you are slicing through something, if you start here and then you're slicing through, you're coming toward the tip as you're going through, you're basically starting a cut in a wide area because of the wider edge. And as you're making it through that cut, the blade is there's less and less blade in thickness. There's less resistance pressing against the sides of the blade, holding it in, causing friction, so you have a high-speed, low-drag blade. You'll see in the opening of this cutting through the fireman's hose. Having a blade that has geometry like this allows you to slice through things so much more efficiently, because there's just very little drag on the blade. So you give it a good sharp edge, and the basic geometry of the edge of the blade is going to make it an efficient cutter, as opposed to one that is the same thickness all the way through, the same edge geometry all the way through. The guard on this is forged mild steel. Wood. And then it's been given a single brass pin. And I opted to not put a butt plate on this, but just run a nice hefty tang into the handle, and it gives it a nice balance point of about an inch or less in front of the guard. So yeah, let's do a little bit more testing with it, see what it can do, and then we'll do a follow-up edge retention test. We'll cut some more of the fireman's hose and see how it gets through. wife hates it when I do that. I'm calling this a shark point. So this would be a shark point buoy. So thanks a lot, guys. Appreciate you always.